Okay, get this. What if the scraps from your kitchen could actually power the technology of tomorrow? It sounds kind of like science fiction, right? Well, today we're diving into a wild idea, turning the peel from a sweet, juicy fruit into a device that could totally change how we store energy.
I mean, really think about that question. It's pretty out there, but scientists are genuinely asking it. We are in this constant race for better, cleaner energy. And you know what? The answer might be hiding in the most unlikely places you can imagine. Like, literally in our garbage cans.
So here's the deal. We're facing this double whammy of a problem right now. First, we desperately need better ways to store energy from renewables like solar and wind, because, the sun isn't always shining. And second, we are generating mountains of agricultural waste. Well, this research, it tries to solve both problems at once.
And this really lays it all out. On one side, you've got our good old batteries. They get the job done, but they charge slowly, they wear out, and let's be honest, making and disposing of them isn't great for the planet. But then, you have the supercapacitor. It's a totally different animal. We're talking instant bursts of power, a lifespan of hundreds of thousands of recharges, and they're way safer. They're pretty much perfect for our green energy grid. The only problem? We need to find cheap, amazing materials to build them with. And this is where our story takes a delicious turn. Instead of digging rare minerals out of the ground, scientists started looking at biomass, specifically at farm waste. And that's where they found a very, very unlikely hero for the job.
Yep, you are seeing that correctly. The lychee peel. The part of the fruit that we all just toss in the bin without even thinking about it. This humble throwaway peel is being transformed in a lab into a super high-tech material for one of the most advanced energy storage devices out there.
Okay, so let's pause for a sec. What is a supercapacitor anyway? Think of it like this. If a battery is a marathon runner, storing lots of energy for the long haul, a supercapacitor is a world-class sprinter. It's all about delivering a massive, powerful punch of energy, like right now, and being ready to do it again and again, almost instantly.
So, how in the world do you turn a flimsy fruit peel into a high-tech energy powerhouse? It's a pretty amazing process, really. It's almost like baking a very, very scientific cake. So, let's break down the recipe. It all starts pretty simply. You dry the peels, crush them into a powder, and mix them with a nitrogen source, which is going to be important later. Then, you bake it in a furnace to make a simple carbon material. But step 3, oh man, this is where the magic really happens. They add a special salt mix and bake it again, this time even hotter. This activation step basically carves out a massive network of microscopic tunnels all through the carbon. After a quick wash, what you're left with is this incredible, super porous, high-tech carbon.
And just look at the difference here. It's absolutely night and day. On the left, you see the material before that final activation step. And on the right, wow. The process has turned it into this complex, beautiful, microscopic sponge. And all those little pores and tunnels, that is prime real estate for grabbing and holding on to energy.
But there's another secret ingredient at play here, and it's got a fancy name, heteroatom-doping. It sounds complicated, I know, but the idea is actually pretty simple. Remember that nitrogen chemical they mixed in at the very beginning? Well, they did that on purpose, to weave nitrogen and oxygen atoms right into the carbon structure. These little foreign atoms act like tiny energy magnets, making the material way better at grabbing ions and moving charge around. It's a simple trick that massively boosts performance.
Okay, so having a cool recipe is one thing, but the big question is always, does it actually work? To find out, the scientists basically set up a championship battle. They created a few different versions of the material to see which one would really come out on top. Let's check out the results.
And the results really speak for themselves. This specific capacitance is just a way of measuring how much charge the material can store. The original version, without that nitrogen doping, was already pretty good at about 255. But look at the champion, NLPPC2. It hit a massive 346.4. That's not just a little bit better, that's a huge leap in performance, proving that whole doping idea was a massive success. Let's just boil it down to one number, 36.1%. That's how much better the champion material performed. Just by adding that one nitrogen-rich ingredient at the start, scientists made the final product more than a third more powerful. You know, in the world of materials science, that is an absolute home run.
But power is only half the battle for a supercapacitor. The other half is durability. How long can it last? Well, the researchers put their champion through the ringer,
an absolutely brutal test of 25,000 full charge and discharge cycles. To put that in perspective, your phone battery starts to degrade after just a few hundred cycles.
And after all of that, it barely broke a sweat. The Litchi peel material still held on to nearly 97% of its original storage capacity. That shows an incredible level of stability. It just keeps going. And that's exactly what you need for the big leagues, like stabilizing a power grid or powering an electric car, where you need something to work reliably for years and years.
Okay, so we've geeked out on the science, which is awesome. But now let's zoom out and look at the big picture. Why is turning some old fruit peels into energy storage so important? What does it all really mean for us and for our future?
Here's the bottom line. This isn't just a cool lab experiment. This is a potential roadmap for more circular economy. It's taking something we think of as worthless, trash, and turning it into a super valuable resource for our green energy future. It's cheap, it's sustainable, and it's pushing the limits of what supercapacitors can do, which helps everybody trying to build a world powered by renewables.
And that really brings us right back to that first question we asked. If we can make powerhouse electronics from Litchi peels, what else is out there? I mean, what about coffee grounds, or peanut shells, or sawdust? This kind of research proves that the big solutions we're looking for might not come from a mine deep underground, but from simply reimagining the very idea of waste itself.